And all right, we're recording Building the Level Part 1. So, all right, so level design equals creativity. And this weekend I had my grandkids over and we break out the Brio trading set. And I let them go to town. And, you know, I'm working with my grandkids and we're building the biggest like train set that you can build. And because we've got boxes of these Brio trains that we've got. And what that is that's early level design. And so if you're wondering, you know, wow, that's really? And you're like, yeah, that's early level design. When you're building train tracks with Brio trains, if you have slot car sets, if you've got HO trains, if you've got Lincoln logs, you know, that you worked with as a kid, Legos, those are all early level design training that you were doing as a kid. And so if you really super enjoyed doing stuff like that, building using Lincoln logs and your blocks and all these other things, then, you know, you might really enjoy level design. So anyway, there's no right way to create a fun experience in level design. You just have to think about, you know, what is fun for me, but what is fun for other people as well. Don't just make it all about what you think is fun. You also have to think about what does my ideal player think is fun as well. And then there's choices to be made, and we get to make choices as level designers, but we always want to give the player choices in the level as well. So we want to give them choices. Options to be weighed. So, you know, a lot of times I might have one space, but I've got 3 good ideas that I want to put in that space. Well, sometimes I'm just going to have to weigh which one is going to be most likely to fit well in the level, to be the most fun, and maybe provide the most challenge. So you've got to weigh these options. You have to begin with a vision. And so I like to give the example of, you know, when you, I've renovated a house before, and I went into this house. Maybe I've told this before, this story. I'll make it quick. But the house was trashed. And my wife and I went in there together, and she's like, really, you want to buy this house and fix it up? I had a vision for what the house was going to look like when it was finished. And so that idea that I had, that's what I started working towards. And I knew exactly how I wanted it to look. And then I just start working towards that. And it's the same in level design, is that you want to start with a vision for what is your level going to look like when it's finished. And that makes things a lot easier, because then all you're doing is just, that's kind of your plan. And then you just start wanting to work that plan until it actually looks like your vision. So that's why you have to begin with a vision. And then as always, in everything we do, we want to learn from our mistakes. And hopefully we learn it that one time and then we don't make that mistake again. And then it's a different process every time, because every level is different and every game is different that we'll be working on. And you know, if you're going to be working on the next Halo level, or whether you're working on the next My Little Pony level, you know, that process is going to be different. And you could be working at a different company and the processes are different. So level designers have to stay flexible, okay, with your work, with how you think about things, how you think about levels. And so, you know, this means flexibility. And there may be lots of trial and error. And some of you have probably been figuring out some of these last 3 or 4 things here, having the vision for my level, learning from my mistakes, you know, a different process every time, lots of trial and error. And so, and if you were thinking, I just, you know, I made all these lights in my scene and my level just took forever to load. Now, you know, maybe that was a mistake to add all those lights. Now you're thinking, I'm just going to have a few lights and really crank up the radius and strategically place them. And so maybe that was a mistake. And so anytime you have things that don't work, write it down, remember it, and learn from it, and pass it on to others as well. And so anyway, that's the idea of level design is creativity. And creativity doesn't mean you're going to do things perfect or right the first time. And so we learn, we move on. Now, when you're designing, and we just want to go full speed ahead, Well, the warning is to restrain yourself. So you may be ready to go, but you need to wait. You need to do some planning. So don't try to tackle everything at once. First, you want to build a functional space. That's kind of where we are this week, is we're building this functional space with our block out, and we're texturing it, and it's got to be functional. So you're going to run through it many times. Second, you're going to add the gameplay and decorative elements, and that's going to be our meshing pass where we add that in. The third one, you test and tune the level. That's going to be our lighting pass where we do that, and we're tweaking the level. And then fourth, you add the polish, and that's our polish pass. So these are the steps that we want to do, because I know a lot of times we just want to go and try to put everything in at once. But it's a process. We have to go stage by stage. And then remember, finally, is that form follows function. It's got to play well and run through well first, and then we can make it look pretty, okay? So function is first, form follows that. All right, what about 2D levels? So 2D levels are limited by depth, meaning we only really see things on the X and Y axis. We're not really looking at the Z axis. There's no depth to them, but we can simulate depth using different ways. So I'm going to skip here. We can have an isometric view, which is like 45 degrees up and 45 degrees over. So it simulates 3 dimensions, even though it's still a 2-dimensional game. Normally we have a fixed camera angle, usually a side view, and you're looking at like a side scroller game. So Mario is a side scroller, and it's a fixed camera angle. So usually we have a large background piece drawn as flat graphic puzzle pieces. They snap together to create a linear environment. Interactive items are placed on top of the background, and probably, again, one of the most popular examples of this would be Mario. Hopefully everybody's played Mario. If you haven't, shame on you. You need to go play Mario today. Don't wait another day if you've never played it, Super Mario. And so, so anyway, light effects, textures are painted directly on the background. So we don't really use real-time lighting because light effects are already painted into it. If you want something to look shadowed or shaded, then it's already going to be painted in there. You're not going to use real-time lights in order to make that happen. So for 3D levels, sorry, it keeps asking me to download and install software, and I'm just not going to do it because it'd take me another 20 minutes to boot up. 3D levels usually tries for realism or resemblance of something that's real, a real world situation, and we focus on textures and lighting to try and add that realism into our level. Now, it doesn't always have to be realism. It can be cartoony as well. But in 3D, sometimes we try to get that kind of a more realistic look to it. And then everything must work in 3 dimensions. And that's really the challenge when you're moving from 2D to 3D, because in 2D, it's kind of easy because everything's flat and you can just do what you want. But 3 dimensions now, everything has to, when it says work in 3 dimensions, that means it's got to look accurate from 3 different dimensions. And that's the challenge, is making it look the same or make it look good from all 3 of those. So, so anyway, now here's the process we're in right now, the Whitebox process. It's also known as blocking out or roughing out. We already went through Blocktober. We looked at that last month when we did our hashtag Blocktober. You can still go there all year long and look at what other people have done to kind of look at the blockout process, and I do recommend that. And blocking out is the process of creating the level to see how it feels to play without concern for how it looks. That's why we add the checkerboard materials on it. We don't really care about the decorations and the textures at this point. We're just trying to see how it feels to play right now. So as you're blocking out your level this week, you should be testing it, running through, playing it. If you've got a roommate or maybe a brother or sister or somebody, ask them to run through your level. Hey, run through it. Tell me what you think, And is it fun? Is it easy yet challenging? And so get other people to run through your level and get their opinions. And it allows the designer to work out problem areas, modifications, cut out unnecessary areas before wasting time on decorations. The further down the line you get, and if you have to make edits or changes, it's going to take longer once you've got more of it completed. So the idea is to work out problems at these earlier stages. And so in the game industry, we like to say, fail fast. So they say, fail early, fail fast. And so that's the thing. And so if you're gonna fail, which you are, do it as early as possible, make your changes, redirect, and then make more stuff. And so that's the idea, is fail early if you can. So, all right, so whiteboxing the level hall. Basically, you're just putting up walls, floors, ceilings, outdoor terrain, doorways, stairs, elevators, walkways. Those are the things that you want in there. Now, in the palace we're working on right now, I've not asked for outdoors. I've not asked for doors, stairs, elevators, walkways. We've done all those before. If you would like to have them in your palace, that's up to you. But I'm no longer requiring these things to have jump pads and teleporters and elevators and all that, because we've done those. So, but anyway, for other models, for other levels, you might have those things. The level hold determines the quality of the player's experience. So again, comes back to testing your level while you're building it. And then important items to address are scale of level elements, the volume of the spaces, and the quality of the construction. Now, several of you learned with our warehouse level, that you just built way too large spaces. They were just huge, and you just couldn't fill them with, you didn't have time to fill them with enough stuff to make them look correct. So now you've learned, okay, I've got to scale my level properly. I've got to be able to realize that I have 1 week for every stage of this, and so I can't make it too large, but I also can't make it too small either, because then it just doesn't feel right again. So the volume of the spaces, the scale of the level elements, and the quality of the overall construction are the things that we're working on this week. So here's a white box level image. We know what they look like. We've made them. Here's one that's just, it looks a little too dark, but you can see there's some stairs, there's some railings, there's some basic lighting, and it's probably ought to be lit up a little bit more. I would require this to be lit up a little bit more. But anyway, here's scale of level elements. So the sense of scale usually comes from comparing things with each other. Now, in some of the levels that we've made, some of the scale, when we've given feedback, we've noticed that the scale of houses, plants, grass, textures, some of those things may be off. And we need to be aware of those things when they're off, and then we need to make them more accurate or correct those things. So when you compare the avatar with a piece of the world to work out general sizing and distance, it's important to have a good critical eye to know, is the scale of my stuff correct? So you'll have to work that out. Now here's an example. So we've come to accept that if a player is this tall, then here's a vehicle. The vehicle could probably be a little bit bigger here, but when it's a real-time strategy game, some things we've just come to accept. Because look at the print. The basic rectangular imprint of the player is this size. It's the same size here. We want the vehicle to fit. And the same size here for this tent. And we want it all to fit on that little square is the point. And so I could make the player like really, really huge to fit on the square, but that wouldn't work because then I can't make the vehicle large enough in order to fit a really super large person and still fit within this boundary right here. So that's the idea. You draw your boundary, and that's what you get everything to fit into. So, all right, what about volume of spaces? So it refers to the amount of space you actually create rather than how much you really need for the final area. So, or how much you'll be able to fill until a room stops looking empty or flat and it starts looking real. And that's the idea. So we've had that with our warehouse. where sometimes they just looked a little bit empty, or we'd put maybe a couple of meshes in there, but the space was so large that it still looked rather empty. So this time we're going to avoid that, and we're going to try and get them to start looking real is the idea behind it. And then other volume considerations is the actual size of the room, and again, make it large enough to be challenging and small enough, is that right? Yes, large enough to be challenging, but still small enough so that you can get it done in the amount of time that we have available to us. And think about how many decorative models will be added later. Well, this week you should be doing research on your theme and discovering which models that you can have to support your theme. And then how many characters will need to move around in the space? Well, for what our level that we're working on currently, our palace level, it's just one character is what we're doing in our space. So one character needs to move around. How big the textures will be for walls and floors. And so again, when we were doing our terrain, some of you had really large grass or rock textures or even dirt textures, and we kind of need to scale those down a little bit to make them look more accurate or more realistic. So this time, as you're choosing textures, think about the scaling issues that you could have and how you need to choose them according to how they will look. Will they look appropriately? You don't want your palace to look like it's a dollhouse, is basically what we're talking about here. It shouldn't look like the size-wise like it's a dollhouse. It needs to look, palaces are large, they're grand. And so we need to make those look like it. What about quality of construction? So the foundation is, the foundation which everything else is built is the quality here. And so we've got some examples of bad geometry. The Z-fighting, we've talked about that before. That's keeping your faces from sitting on top of each other. And so I've got an example here in just a moment. Floating geometry, structural holes, complex shapes. These are all things that we do have to deal with, but there are fixes for these. So for Z-fighting, here's an object. There's two objects sitting on top of each other. It was by accident. Somebody duplicated it and didn't move it. And so now you can see this little pattern right here happens. And you'll notice that it's kind of divided down the triangle right here. And that's because the video card can't decide which of these images it wants to display first. And so is it going to display the mesh A or mesh B? They're occupying the same space. And so that's why you get as you move and it flashes, it just can't decide which one to shine. Here's an example of floating geometry. Here's a picture on the wall, and we're looking towards the side of it, but this level designer didn't put it all the way back up against the wall. So if the player comes over here and they look this way, it kind of takes them out of that, we're trying to immerse them in believability, and it takes away from that immersion and believability when we see things floating around. So we need to take those pictures and smack them right up against the wall there. So we don't get this floating geometry there. All right, so those are some things and fixes. Now, let's talk a little bit about building the level. And so here's one way to build a level. Popular level building approaches. So you can build it in sections so that if I'm on my team, I'm working on a game, and I've been tasked with building a number of levels. Let's say I get 5 levels that I have to build in the next, 6 months. So it gives me just over a month per level to build. So I'm going to go and I'm going to build the first one, map level, same thing. I'm going to build the basic geometry for the first level, and then I'll put my gameplay elements in, and then I'll do my deco, and I've done that for the first level. Then I'm going to go and I'm going to work on the second level, and so that's like 3 weeks. Let's take a week of doing each of those. Then I'm going to go to my second level, and I'm going to do my geometry, my gameplay elements, my deco, and then that's 3 more weeks, and then I'll go into my third level. So I'm kind of pacing myself doing this and building these out, and this is called doing it in sections, okay? Now here's the advantages to building your level in sections. You can have a relatively finished map at any stage, because I've got those 3 things in there, I've got my level built. I've got the meshes and the textures, the gameplay elements. It's in there. So if somebody calls up and says, hey, we're moving the timetable up, we got to get this game ready, 3 weeks early. Well, all right. Well, my levels are pretty much finished at this point. They need tweaks and things. And so I can stop at most any point to finish the game. I can fine-tune the visuals while I work on it, and it allows you to quickly build a full prototype for the team to see. Meaning, I've got my first level pretty much built and done, so anybody can start play testing it and seeing what's going on. It also allows for creative types to maintain concentration by jumping around area to area. Meaning, I'm blocking it out, I'm going putting my gameplay elements and putting my meshes and my textures on it and stuff like that. But what are the disadvantages to building it this way? Well, it skips the pipeline. Remember, we've talked about the pipeline, that if I'm going to go ahead and build my level and I'm going to get the first level worked on, so I've got my block out, not a problem. Here's where we skip the pipeline. I'm ready to put meshes and textures in my level. But the pipeline says that, hey, my 2D artists and my 3D modelers, prop modelers, they're not going to be ready with this stuff yet because it takes time to build those things. So they may not be ready for 2 or 3 months to have the textures I need and to have the models that I'm working with. So I may just have to put placeholder things in there for now. So I'm not really having finished pieces by skipping the pipeline here. So I may not have all the art assets available. The process is chaotic because I'm swapping in placeholder and swapping out objects. And the designer may focus too much on one area and neglect other areas. And so what's another way then? What else can I do? Well, here's what else you can do. You can build in layers. So I can take every map and I can build out the geometry. Oops, sorry. I silenced it, and I got to figure out how to use that thing. I silenced it, and I'm not sure why it's ringing. All right, so I apologize. All right, so from map start to map end, basic geometry. This is the whole thing. So I'm building out basic geometry. Then when I'm done with that, I'm coming back and I'm putting all the gameplay elements in there. Then when I'm done with that, I'm putting all the decorations in there. So what's the difference? So working the level in a series of passes or layers. So then what are the advantages and disadvantages of this one? The advantages is the people supporting your map have time to do their work. That means we're using the pipeline, okay? By the time I get done, where is it? By the time I get done with all this basic blocking out and everything, and I do that, then my supporting team, my 2D artists, my 3D prop modelers, they have time to get their work done. And so it also allows for early testing because I've got all my levels blocked out. And then I can see early on if the level meets the goals of pre-production. So that's that thing where we want to fail early, and this allows me to do that. What are the disadvantages? Some people, it's hard to focus on that one task per week. Like if all I'm doing is basic geometry for 2 months, blocking out, that could be a challenge to just sit there and block out for 2 months. Some of you might be thinking, yeah, I'm doing it for a week and I'm already tired of it. Well, think about blocking out for a couple months. So it's hard to focus on just doing that one task for weeks. It's not much fun to create untextured, visually uninteresting white box geometry. So if that's what I'm doing for the next month, sometimes it's just not fun and you want to move on to the next stage. And it's hard to finish if a deadline is moved up. Because think about that, if a deadline is moved up, and before we had all 3 of these things completed on each one of our levels, so if worse came to worse, I'd just cut out some levels. But here, all I'm doing is all 5 of my levels, I'm doing basic geometry, all 5 levels. Then, and I did that over, we'll just say 5 weeks, a week per level. Then I go back and I put all gameplay elements. And halfway through gameplay elements, the team lead comes and says, hey, we got to move our timeline up, by 3 weeks. They want us to deliver our work early. You've got nothing finished. None of your 5 levels are finished at this point, not even close. Because you've still got to finish gameplay elements in all of them, and you've added no deco in any of them. So that's one of the challenges of doing it that way. And so it's hard to finish if a deadline's moved up. So immediately I got to drop what I'm doing and start putting deco in some of the levels that I've at least got other things in. All right, now, so there's two different approaches we've looked at. What about if you figure out maybe a better way or customize your process? So you can find the system that works for you. Focus on each task one by one until you're finished, or you can stay focused by flitting from one area to another on an hourly basis. You know, you really have to figure out, once you start doing this on a regular basis, what is going to work best for you, your working style, and for your team. What is going to be best for the team to be able to see progress every day when you have your meetings. And so you kind of have to customize how you're going to build stuff. And so anyway, you can do that. Now, let's talk about optimization techniques. So optimization techniques, this is your responsibility for keeping the level playable. So you got to figure out how much geometry is in the level. Some of you figured out with foliage and lighting that, wow, I put all this foliage in, it made my level look really cool, but then it took hours to build, or I'm running around and then all of a sudden I turn and look at this field full of grass and trees and my frames per second just dropped drastically. It's because you were using trees that had too many leaves on them, or they were high poly trees, and you're using all this grass, and you need to use low poly grass if you're going to use a lot of it. So you got to figure out how much geometry is in my level, how many textures, how many lights, and just make sure the level never bogs down the target machine. Well, how do I know what's going to do that? Play testing. So much of it revolves, you hear people, gamers in the industry, they're like, oh yeah, we play games all the time. Some of it is just playing their levels over and over and over again to test it and make sure it's working properly. So yeah, you're playing games, you're playing levels, and some of it is just to test it and make sure it's working properly. Zones and portals. So you want to break the map into smaller sections that get shown to the player only when the engine determines he should actually be able to see them. So here's an example. We've looked at a little bit of this before, but here's how to use this. If we have, instead of having one big large room here, we're going to break this up into two different sized rooms. We'll have a little tunnel or a little hallway in between them. And here's the player's range of vision. So it's a little longer than 90 degrees. It looks like maybe 100, 110 degree there vision. And the player can see here to here. So everything they're looking at is what they can see here. And so but this entire room gets rendered. So maybe there's a door or something blocking here, because even if the player turns and looks this way, they won't be able to see things here. So we're not even going to render that. The machine's not going to render that information. So we don't have to worry about having too many trees, combination of here and here. We don't have to worry about that. So when the player goes through here, they walk through the door, then this room is the zone not rendered, and this one all of a sudden becomes the one that's rendered and the player can see. So we've developed these techniques in order to be able to have a large space like this that the player can play in, but we're going to divide it up into two to make it so it's more efficient for the computer to be able to run it. So now that we're in 2021, we've got these really powerful video cards. We've got very powerful, fast processors. This is not as much a concern, but it is still a concern. Because like some of you figured out, again in your terrain levels, that, wow, I still can't have these super high poly trees in my level and have a lot of them because it just slows down my level. Well, is there anything you could do to block the view of some of those trees and then they wouldn't get rendered? Put a large hill there, a mountain, a volcano, to block the view from there. And so if they can't see it, it doesn't get rendered. So anyway, and so that brings us actually to my next point, which is occlusion objects. And so I just mentioned having a volcano and a mountain or something like that. So it's sometimes impossible or undesirable to use zones, especially in outdoor areas like our terrain. So you can't seal off the outside environment. So what we do is we build these occlusion objects. And so occluders are objects that tell the engine not to render anything that blocks the player from seeing it. And so that was one of the reasons that I wanted you to have hills and in your level, hills and valleys, is because it limits the amount of things that the computer actually sees when you're playing it. And it helps optimize your level. And so, but you can put other things in there. You can have building structures, things like that that can block out. All right, so this is how it works. So how many of you have ever played a game, and it doesn't matter if it's first person or third person, and you walk into the reactor room, right? The reactor room. And you're thinking, wow, why are there so many games that have reactor rooms in them? It's a large room, and it's got a huge reactor right in the middle of it. And you might be thinking, well, I guess that's just standard for this type of game. You know, a first-person shooter, third-person shooter. What's going on here is the reactor is acting as an occluder. And so, because here we've got all these objects, right, that are around, we want to put more meshes, more textures, all these things inside of our level, but we can't have them. So the player's range of vision is right here, and they can see everything. And it slows down our frames per second. So what we discovered, decades ago is why don't we just put some large object right in the center of our level or of this room, and it will occlude objects so they don't get rendered. So this occluder, that could be our reactor, now at any given point, it's going, no matter where the player moves, it's going to be blocking at least two of these objects. So these two get blocked. This one can be partially seen, so it's still visible. Yeah, Roger.
So just to clarify, you're saying that these objects behind us that are behind the reactor, they're not actually loaded, so they're actually close within the player is able to see.
That's exactly right. They don't get loaded or rendered, either whatever you want to call it. They don't get loaded or rendered until the player can actually see them. And so in this case, the player, if we didn't have this occluder, 1, 2, 3, 4, 5, 6 objects here that would be rendered, but it could slow down my frames per second. So by putting this occluder here, this reactor, it gets rid of 2 of these pieces that aren't going to be rendered. So now with seeing only 4 of those at any given time, my frames per second will stay at a maximum point there. So that's the idea behind it. All right. So what about, so that's it for occlusion objects. Let's talk about spawners. So spawners are needed because of the limits of AI and calculating too many moving objects at a time. So if we have monster spawners, so that way instead of giving a player 100 enemies to deal with, why don't we put a monster spawner in the level, and it's going to spawn like 1 per second. And that way on screen, there might be 20 or 30 on screen at any given time, because the idea is that the players should be fighting against them and destroying them, so that as they're destroying the first 20, 20 more are coming on the scene. So over the course of a couple minutes, they're destroying them as they're being spawned, but they still have to destroy 100 of them, but they're not all on screen at the same time. So a marker tells the game engine when the player activates a certain trigger, create an enemy NPC where I am. And so spawners are just simply markers in the map in whose property attributes you set the number and type of actor to create and when. So that's a simple blueprint. It's just spawn actor is the blueprint. And then when the player, and then you have a, maybe the player has an axe, and whenever they hit the monster with the axe, then they're destroyed, and that's just destroy actor. So spawn actor and destroy actor are all we're doing here with spawners. So pretty simple blueprint to be able to do those types of things. All right, so how do I know if my game is going to run efficiently, if it's going to run smoothly, if I'm going to keep my frames per second nice and high? Basically, I know I harp on this, you're just going to have to test your work constantly, which means play your game. Make sure it plays like you want it to. Make sure that it looks and sounds like you want it to. Make sure that it evokes the kind of mood and ambience that you were aiming for, and see where you need to make changes. You may need to sacrifice some really cool looking trees and have less cool looking trees. And those are just sacrifices we have to deal with. Noah, I think it was you that had the flat pictures of trees and they were billboarded, and that was a good solution. It's a little bit of a sacrifice to get the trees don't look 3D, but we still accept that in video games because it's still a high quality picture of one. So it's a small sacrifice to make sure that our game runs efficiently, and content additions by the request of others, that things that we want in there. The game designer may come in. My lead level designer may come in and say, hey, why don't you add some of these in there? Put some more of these, less of these, add this really cool building. The 3D modelers thought that this really high poly model would go really good in your game, so make it fit somewhere, And then those are things that you just kind of have to deal with. So, all right, so we talked about a lot. So in summary, ensure that you have a clean level. So you've got geometry, you've got the BSP that we work with. Keep a cool head when dealing with scale and volume issues. Make sure to test it, to look at it, make sure that your scale is correct. Ask other people to give you feedback before we have our class critiques. And so take time to work out your scale and your size issues of meshes and things like that. You can scale them down. You can bring things, if you find something on the internet or in the marketplace and it's too big or too small, bring it back into 3ds Max or Maya, scale it up, or Blender, scale it up or scale it down, whatever you need, and then re-export it and the right size, or you can just rescale it in Unreal because there's scaling in there as well. Pick a construction method that works best for you and allows you to stay on schedule, and then optimize your map constantly. So you're always testing it, you're always optimizing it, making sure that it runs smoothly and looks good. That's kind of the things that we're going for at this point. So, and that ends the theory for the day. All right, go ahead and if you'd like to take a break, get a drink, go breathe some fresh air, some non-mask filtered air, you can do that.